Good afternoon. This lesson is going to be on right triangle trigonometry. A triangle in which one angle is a right angle is called a right triangle. The side opposite the right angle is called the hypotenuse. And the remaining two sides of this triangle are called the legs. So here's your right angle, across is the hypotenuse, A and B are legs. Theta, the Greek letter theta, is what we're going to use to represent the acute angle in this triangle. The 6 ratios of a right triangle are called the trigonometric functions, and the function name is listed here on the left. This is how we read them: the sine of theta, the cosine of theta, the tangent of theta, the cosecant of theta, the secant of theta, and the cotangent of theta. On the right-hand column, these are the abbreviations. This is how we write them. When we read this, we say the sine of theta. We read this the cosine of theta, not sin theta, not cos theta, etc. The 6 ratios of a right triangle are called trigonometric functions, and we're going to define them using the sides of the triangle: the opposite side, the adjacent side, and the hypotenuse. If theta is located here, then the opposite side is side B, because it is across the triangle from theta. That's opposite. The hypotenuse is the side that's always opposite the right angle. And that leaves this side to be the adjacent side to theta, which is the one next to it. The sine of theta is defined as the opposite side, which is B, divided by the hypotenuse, which is C. So this is the length of the opposite side divided by the length of the hypotenuse. Cosine of theta is defined as the length of the adjacent side divided by the hypotenuse. And the tangent of theta is defined as the length of the opposite side divided by the length of the adjacent side. Then we have the cosecant of theta, which is the hypotenuse divided by the opposite. I hope you will notice that these are reciprocals of each other. The sine and the cosecant are reciprocals. The secant is the length of the hypotenuse divided by the adjacent, so cosine and secant are reciprocals. And the cotangent of theta is the adjacent divided by the opposite. That is the reciprocal of the tangent. In example 1, we're asked to find the exact values of the 6 trig functions. We're looking for the 6 trig functions of angle theta in this figure. Well, I know that I can use the lengths of the legs and the length of the hypotenuse to find that. So we need to find out what the length of this other leg is. If I know my special right triangles, I can just say, well, that length is 4, because this is a 3, 4, 5 special right triangle. Notice that with a 3, 4, 5 right triangle, the hypotenuse always must be the length 5 because it has to be the longest side. If you didn't recognize this as a special right triangle, then you could have used the Pythagorean theorem, and you could have said a squared plus b squared equals c squared, where we're going to use b is 3 and c is 5. So we still come up with the fact that side A is 4. Then we're going to define our 6 trig functions: our sine, cosine, and tangent, cosecant, secant, and cotangent. The sine is the opposite side, 4, over the hypotenuse, 5. So the sine of theta is 4 over 5. The cosine of theta is the adjacent side over the hypotenuse, which is 3 over 5. And the tangent is the opposite side over the adjacent side, which is 4 over 3. Then we just need to take the reciprocals to find the other 3 trig functions, because the cosecant is the reciprocal of sine, so that's 5 over 4. The secant is the reciprocal of cosine, so that's 5 over 3. And the cotangent is the reciprocal of the tangent, so that's 3 over 4. Complementary angles and cofunctions. 2 angles are called complementary. So you need to write complementary in this blank if their sum is a right angle. The sum of the angles of a triangle equals 180 degrees. So you need to write 180 degrees here. Therefore, the two acute angles of a right triangle are complementary. Because if these three angles must add to be 180, as in our second statement at the top, this angle is already 90 degrees, then these two angles have to add to be 90 degrees, which will make them complementary. Now, when we are looking at this triangle, I need you to be sure that you understand that when I take angle beta and I look across the triangle from angle beta, that side B is the side opposite of beta. Side B, if I'm looking from angle alpha, side B is the angle that is adjacent to alpha. So side B is next to or adjacent to alpha and across from or opposite from beta. Likewise, side A is opposite angle alpha but adjacent to angle beta. Now this idea is going to give us some definitions of our cofunctions. So we want to look now at the cofunctions. The sine of beta, here's beta, I'm going to look at the sine, the opposite over the hypotenuse, so that's B over C. That's the same thing as the cosine of alpha. The cosine is adjacent over hypotenuse, so the cosine of alpha is side B over side C. So the cosine of alpha is the same as the sine of beta. If I look at the cosine of beta is A over C, adjacent over hypotenuse. That's the same thing as the sine of alpha, because side A is the opposite side and C is the hypotenuse. So the cosine of beta, A over C, is the same as the sine of alpha, A over C. If I look at tangent, I can see that the tangent of beta, opposite over adjacent, B over A. Well, that's the same thing as the cotangent of alpha. The cotangent of alpha is adjacent, which is B, over opposite, which is A. So the tangent of beta is the same as the cotangent of alpha. They have the same value. Then, if we're going to do the reciprocals, then that means that the reciprocal of sine is cosecant, the reciprocal of cosine is secant. So I'm going to flip this over to get C over B, so that cosecant of beta is going to be the same value as the secant of alpha. The secant of beta, which is the reciprocal of the cosine, is going to be the same as the cosecant of alpha. When I flip this over, I'm going to get C over A. And the cotangent of beta is going to be the same as the tangent of alpha. These functions are called cofunctions. The sine and the cosine of the acute angles in a triangle are cofunctions of each other. So the sine of beta is the same as the cosine of alpha. The cosine of beta is the same as the sine of alpha. The tangent of beta is the same as the cotangent of alpha. So sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. Now, let's talk about what the complementary angle theorem says. This is very, very important, so I need you to be sure that you write this down and put a box around it, highlight it, something, so you'll know that this is important. Oops, I'm sorry. Let me back up. The complementary angle theorem says cofunctions of complementary angles are equal. Complementary angles are angles that add to be 90 degrees. So if two angles add up to be 90 degrees, then the sine of one of those angles is equal to the cosine of the other of those angles. Let's look at some examples. So examples of complementary angle theorem. The sine of 30 degrees is the same as the cosine of 60. Sine and cosine are complementary. I apologize. The sine and the cosine are cofunctions. 30 and 60 are complementary. 30 plus 60 is 90. So these two angles are complementary, which means that the sine of 30 has the same value as the cosine of 60. Tangent and cotangent are cofunctions. 40 and 50 are complementary. So by the complementary angle theorem, it says that tangent and cotangent, being cofunctions, the tangent of 40 degrees and the cotangent of 50 degrees have the same value. The secant of 80 equals the cosecant of 10. The first thing I notice here is that 80 plus 10 is 90. So these are complementary angles. Secant and cosecant are cofunctions. So the value of the secant of 80 degrees is the same as the value of the cosecant of 10. Okay, example 2. If I ask you to find another trig function and another angle that have the same value as the sine of 62 degrees. The first thing you would think was, well, sine and cosine are cofunctions. So if I've got the sine, the cofunction is going to be the cosine. All I need to do now is find the complement to 62 degrees. I can do that by saying 90 minus 62, which gives me 28. So the sine of 62 degrees is equal to the cosine of 28. If I give you the tangent of 40 degrees and say, please find another function, trig function, and another angle that has the same value as the tangent of 40 degrees. The first thing you would think is tangent and cotangent are cofunctions. And if I take 90 and subtract this 40 from it that I already have, I'll find the complementary angle. So the complementary angle to 40 degrees is 50 degrees. So the tangent of 40 is equal to the cotangent of 50. Now, some things that I need for you to be sure that you study and remember. The first of your trig identities. These are going to become very important over the next 6 or 8 weeks as we study more into the trig. So you need to start memorizing these right away. The reciprocal identities. We already said that the cosecant is the reciprocal of the sine. So we can write cosecant of theta is equal to 1 divided by the sine of theta. The secant is the reciprocal of the cosine. So I can write the secant of theta is equal to 1 divided by the cosine of theta. And the cotangent of theta is the reciprocal of the tangent of theta. So the cotangent of theta is 1 divided by the tangent of theta. The next identities that you need to memorize are your quotient identities. The tangent of theta is equal to the sine of theta divided by the cosine of theta. You need to know that if you want to rewrite the tangent in terms of sine and cosine, that you will use your quotient identities. The tangent of theta is equal to the sine of theta divided by the cosine of theta. And likewise, since the cotangent is the reciprocal of the tangent, that means that the cotangent of theta is going to be the cosine of theta divided by the sine of theta. All right, let's look at this problem right here. This is a right triangle. I know this because there's a 90-degree angle. If I look at the Pythagorean theorem, a squared plus b squared equals c squared, and I want to use that Pythagorean theorem because I know it's true, I know it holds true for any right triangle, that the square of the two legs added together is equal to the square of the hypotenuse. So the sum of the squares of the two legs of any right triangle is equal to the square of the hypotenuse. If I wanted to, I could divide all three of these terms by c squared. I'm doing that so I can get a 1 right here. What I'm about to do is prove your next identity for you. So I'm dividing all three of these terms by c squared so that I can get a 1 over here on this right-hand side. Now, by the laws of exponents, I know that a squared divided by c squared is the same thing as a divided by c, that quantity squared. So I'm just going to rewrite it that way. I'm going to take b squared divided by c squared and say, well, I know that's the same thing as b divided by c squared, and c squared divided by c squared is equal to 1. Now, the next thing we're going to do is look at what a divided by c is. I want you in your notes to take your theta and put it right here. I should have written it right up here and I did not do that. I apologize. So put your theta right up here in this top angle. This is where I want our theta to be. And if theta is right here in this top angle, let me see if this will let me get the pen and I'll write it right here. Let's put theta right here. Ooh, that's not too beautiful, but you got the idea. Okay, so there's theta right there. Okay, so if that's theta right there, then this A is the opposite side. C is the hypotenuse, and B is the adjacent side. So A divided by C is opposite over hypotenuse, which is the same thing as the sine of theta. So I have the sine A over C squared plus B over C, that's the cosine squared. So B over C squared is the cosine squared, and that's equal to 1. So this identity, sine squared theta plus cosine squared theta equals 1, is called my first Pythagorean identity. You need to know this along with your reciprocal identities and your quotient identities. All right. To solve a right triangle means that you need to find all of the missing side lengths and all of the missing measurements of the angles. So you have to by the time you finish solving a triangle, you have to know all three sides and all three angles. So let's look at this example. Let's use the figure. If A is equal to 4, okay, so this is A right here. This is A. Okay, A is equal to 4. We have B right here. Okay, and we have C right here. We know alpha is 35, so I'm going to put alpha right here. Okay, alpha is equal to 35. I need to find side B, side C, and angle beta. Okay, well, the first thing that I know is that I could use the sine of this angle that I know, because I have the sine of 35 degrees is the opposite side over the hypotenuse. Now, this is not the only way to start, but it's just what I thought of to do first. If I take the sine of 35, which is 4 over c, then I can quickly and easily solve this for c. Okay, I'm going to say multiply both sides by c so that I get c sine of 35 equals 4, then divide by the sine of 35. I'm going to go to my calculator and type in 4 sine of 35 degrees. That's going to give me about 6.97. Be sure that your calculator mode is degrees. Okay, make sure that your mode, the mode on your calculator is in degrees. Okay, ooh, I can't write very well, but this is okay. You got it. So you want degree mode. You want degree mode. Let's see if I can do cursive better then. So you want to be sure you're in degree mode. Okay? Check your calculator mode. If you don't have it in degree mode, you need it in degree mode. Okay, then I can say, well, now that I know that side C, and let's go ahead and do that. I'm going to change my pen color real quickly. I think I'm going to change my pen color real quickly. Let's make it blue. And I know now that C is about, and we're going to use approximate signs, about 6.97. And we are going to now find out what side B is. Okay, so side B, we're going to use the tangent because we need B. We don't want to use this 6.97 to try to find the tangent or to try to find any other piece of information because we've rounded this. We always want to go back to our given information. Plus, if we made a mistake here, then that would make all of our answers wrong. So I'm always going back to my given information, which is the 4 and the 35. So I know that the tangent of 35 is equal to the opposite over the adjacent. So the tangent of 35 is 4 over B. So that's what I'm going to use. I'm going to multiply both sides by B and then divide by the tangent of 35 degrees. Making sure my calculator is over here in degree mode, and when I do that I find out that B is about 5.71. So B is approximately, ooh, that's funny looking, approximately 5.71. Okay, 5 point, you can't see the decimal there, 5.71 is approximately what my B is. Okay? Now, all I need to find, because I have all three sides now, all I need to find now is what beta is. And hopefully you will remember that these two angles have to add to be 90. So in order to find angle beta, all I have to do is take 90 minus alpha, which is 35, to find out that my angle, not my side, beta is equal to 35 degrees. Okay? All right, there we go. That's solving a right triangle. Notice I have, oops, I wrote 35. I'm supposed to write 55. Let's fix that. This is supposed to be 55 degrees. Let's see if we can make this into a 5. Sorry, that was my mistake. I was reading it incorrectly. Had my answer over there and still wrote it wrong. Okay, so 55 degrees for beta, 35 degrees for alpha, which we were given. Side A is 4, side B is approximately 5.71, and side C is approximately 6.97. Solving a right triangle. Okay, example 3. A 25-foot ladder is leaning against a wall and forms an angle of 70 degrees with the ground. How high up the wall is the top of the ladder? The first thing you should do here is draw yourself a picture. Okay, so what I have is I have a 25-foot ladder. So here's my ladder. It's leaning against a wall. It forms an angle of 70 degrees with the ground, and I want to know how high up the wall does the ladder reach. So the first thing that I notice here is that if 70 degrees, this is my right angle right here, okay? My right angle is here. If I have an angle of 70 degrees that I'm looking at, across from 70 degrees, that's my opposite side, that's what I'm looking for, and my hypotenuse is the one that's across from the right angle, so that's my 25. So I've got opposite and hypotenuse given to me. So I want to find the sine of 70 because that's opposite over hypotenuse. And then all I have to do is multiply both sides by the 25, and I can find out that the height is about 23.49 feet. All right, angles of elevation and depression. This is a review from geometry if you took Algebra 1, Algebra 2, and geometry, or should be from Math 2 or Math 3 if you took Math 1, Math 2, Math 3. The angle of elevation, if a person is looking up, okay, looking up at an object, the acute angle that's measured from the horizontal, okay, Here's the horizontal. That's if you looked straight ahead, that's your horizontal line of sight, and then your elevated line of sight. The angle in between the horizontal line of sight and the elevated line of sight is the angle of elevation. An angle of depression is when a person is looking down at an object. If a person was standing on the cliff and he was looking down, then the acute made by the horizontal line of sight and the depressed line of sight, okay, this angle right here is the angle of depression. Please be careful with this. A lot of times students will try to make the angle between the person and the line of sight the angle of depression. This is not the angle of depression. The angle of depression is if he was looking straight forward, his horizontal line of sight, and then he looks down, the angle that's between those two lines of sight is the angle of depression. Okay? All right, let's look at example 5, and I'm going to get you started on this, and I'm going to ask you to try to finish this one on your own. Meteorologists find the height of a cloud using an instrument called a ceilometer. A ceilometer consists of a light projector. Okay, here's your light projector that directs a vertical light beam up to the cloud base, and a light detector, here's the light detector over here, that scans the cloud. It'll scan back and forth on the cloud to detect the beam of light. On December 13th, 2001 at Midway Airport in Chicago, a ceilometer with a base of 300 feet. Okay, the base is the distance between the light detector and the light projector. There's the base of 300 feet, was employed to find the height of the cloud cover. We need to find the height of the cloud cover. If the angle of elevation of the light detector is 75, what is the height of the cloud cover? Okay, I want you to try to solve this problem on your own. I will discuss this problem with you tomorrow in class, not tomorrow, Monday in class, and we will see what you've done with that.